All right, thank you all. So we had the whole show of hands. First of all, who likes pizza? That's just a ruse. There's a lot of people here who don't have their hands up. That was a blatant ruse just to get you to actually practice putting your hand in the air. A couple of things I just want to ask before I kick off. I gave a very, very similar version of this talk at the Contain meetup a couple of weeks ago. Did anyone see that? All right, you guys can skip straight to the pizza part. Don't miss Anne's talk, obviously. Now, I also gave an introductory Kubernetes talk at DevOps Exchange at Boys School in East London about 6 months ago. Who was there for that? All right, so in general, we're working under the assumption now that we're all, yep, Docker, hooray, that's great. And we're all sort of roughly familiar with where Kubernetes is, or at least what it is. I'll talk very quickly to it just to cover that off. But for everyone else now, it's like, what's the next thing? And like the question is, we are still pre-1.0 at this stage. A few hands went up, are you running it? Well, you should probably wait until we get to 1.0. We're very close to that, and I want to tell you about what we're doing and also how we got to where we are today. So I am Craig Box, at Craig Box at Twitter. I'd love it if you all sent messages, said hello. The photo that lovely gentleman's taking there with the luscious beard, he can post on Twitter afterwards. So Kubernetes, for those of you who have not heard of it, is a Greek word, which a gentleman in an audience earlier today told me off for pronouncing wrong, but I said I pronounce it better than most of my American colleagues, so apologies to any Greek speakers. But it's the root of the English word governor in cybernetics. So while it's a little bit of a mouthful, it's a really good descriptor for what it is that this system does. And what it is an evolution of the container cluster orchestration systems that we run internally at Google over the past 10 years. So Google has invented a lot of computer science. A lot of the foundational research of computer science has been done at Google. Unfortunately, from some of the things you've heard about in the last talk, we can't ship you a paperback book, but rest assured we know how to run computers at scale in a way that few other people do. So Kubernetes takes the fact that we're all using Docker today, we're all very familiar with these concepts, or we're gaining familiarity. It's something that's taken off in the ecosystem. And it's saying, well, we want to bring our foundational knowledge in how to build clusters, and we want to be able to use the tooling you're familiar with today and help guide the world to be able to get the benefits that we've seen internally, so you're able to do your computing in the same way. In order to do that, we need to be able to run in multiple environments. So I work for Google Cloud Platform. We can run this with a single click with our container engine, which I'll talk about. But you can also take this code and you can run it on Amazon. You can run it on Rackspace. You can deploy it with Vagrant on bare metal. You can deploy it with OpenStack. Anything you want to do. This is a foundational layer which should be able to run anywhere if we've done our job right. It needs to support existing open source applications as well. So we can't assume people are all going to rewrite code in order to be able to work in this brave new world. And even if they do, there's a chance that they'll need to call out to a pre-existing database, something that predates this world. So we've needed to factor that in from the beginning. It's 100% open source. It's on GitHub. It's written in Go. And summarizing it in a sentence, they say Kubernetes is to let users manage applications and not machines. Just a quick introduction to the four major concepts. So we have a thing called a pod, which is a small group of tightly coupled containers. We find that quite often you'll want to have a web server perhaps, and then it also needs to have a different container which accesses its logs and uploads them to one of the operational services that John was talking about before. Or you might have the code, your PHP code is deployed alongside the container that hosts Nginx, but you want to have different teams update them at different schedules. So we don't schedule a container to run as such. We schedule a pod, which can contain one or more containers together, and they will be guaranteed, they are strongly coupled, so they are run together on the same machine always. But you may have clusters with thousands of machines effectively, and you want to have these services which support huge internet scale workloads. So we have a replication controller, which is a loop that says, I want to have 100 instances of this particular pod running in my cluster, and then it will go out and first of all, the master will go out and find places to run this, and if one of those nodes fails, or if something else with a higher priority comes along, we might need to run that somewhere else. So we will continually go through, we get a state definition, which is a config file you give at the beginning, which just says, here's what I want. Instead of flying the plane, you program the autopilot. You tell it where you want to go, what your end result is, and the system delivers it for you. A service is a set of pods that run together, so you might have one part of your greater application needs to connect maybe with to a different microservice, but again, that could be scheduled on dozens of machines, and you just need to talk to one of those instances. You have complicated service discovery where you have to rewrite your application and say, call out to this thing and ask and then find wherever. What we do is we use services which are a proxy running on their own IP address. So your application just says, connect to this known endpoint, and it handles it all for you. So it abstracts away the concept of service discovery. And that's achieved using labels, which are just arbitrary tags that you can apply, which enable things to tell a replication controller what it needs to run, for example. So that's the 1-minute introduction to what Kubernetes is. There it is in the slide. It's given a bunch of places. Where are we going to put all our internet cats? So we open sourced Kubernetes in June 2014, which is just over 1 year ago, a year and a couple of weeks. We launched a hosted version of it a few months afterwards, which is, one of my colleagues described, we have wild Kubernetes, which is the open source version, and then a tame one, which you can click on and just deploy. It deploys compute engine nodes and a master and handles all of the networking setup for you. We'll talk a little bit about what to do if you're not running on that. But if you're interested in getting started, it's a very easy way just to do one-click setup, become familiar with it. We're working with a bunch of partners. I'm sure I have all their logos coming up, but just to name a few of them, Red Hat have been building their version 3 of their OpenShift platform as a service on top of Kubernetes. How they've been doing this is fantastic. They've been contributing all of the things underneath that they need to make this possible into Kubernetes and then just keeping their pieces, again, open source in their origin repository. But that's going GA very soon as well. And we've had some great work with CoreOS, who again have a sort of an enterprise one-click thing called Tectonic, which they're building on top of Kubernetes. We have a great partnership with Mesosphere, who I'll talk about a little later on. So they'll let you run Kubernetes on top of Mesos if you want to coexist with, say, big data Hadoop workloads. Anyone here running or investigating Mesos? A few hands. All right, and again with a company called Mirantis, who have packaged up Kubernetes to run on top of the OpenStack framework in their application library. So where we are today, we are driving very, very quickly towards a 1.0 release. We are targeting what might seem like a small number of nodes. So we want to be able to do two things. First of all, we have a stable API. We'll talk a bit about that later on. But we're saying that for a small cluster of 100 nodes and 30 pods per node, so still, again, that's 3,000 containers you're able to run. That's what we're testing for in our 1.0 release. We may well be able to run more than that. And over the course of the rest of the year, once we've gone past this line in the sand we're calling 1.0, we'll be building out to be able to support many more nodes. We have a roadmap link there, which if we send out at the meetup group afterwards, I'll probably send the slides or at least some of these links. This isn't something that we've been building by ourselves from the beginning. We've been collaborating with some great people in the open source and sort of traditional enterprise IT spaces. We really want this to be something that people can run in their own data center. We saw some great uptake from Microsoft at the beginning of people being able to run this on top of Windows Azure. As Microsoft build out their own container system with Docker, there's no reason to say that you wouldn't be able to use the Kubernetes system to schedule Windows workloads running on top of Windows as well, which some people may find very interesting. All right. All right, so that's the sort of potted overview. Not entirely sure. The projector seems to only want to do the color up to a little bit of that corner, so it's just to show that it's all red where I see it. So first little hint I like to give here is the internal code name for Kubernetes. We have our Borg cluster management system internally, so we wanted to build a system out. So the code name was Project 7, and the goal was we wanted to build a more attractive Borg, but unfortunately when it came to the naming people, we weren't able to slip that one past them. Why did we want to build Project 7? Well, the question is, how can we, as Google, help the world go cloud native? Our data centers were built from the ground up for a container-packaged, dynamically scheduled, service-oriented architecture. Now, no matter how cheap or how wonderful we are at hosting all of this stuff, as John said before, no one wants to be locked into a single provider. No one wants to think that I can only run in this one place. So we needed to build something in the open We wanted to build something that was like what we had before, but it didn't have to descend from it. We wanted it to be pattern compatible. So you'd use the same ideas, but you wouldn't necessarily need to. We wanted to fix the mistakes we'd made in the past. We wanted to be able to say, now that we know what we know and other things have moved on, what would we do differently if we were to build this again? And that's exactly what we did. So a few other things that we wanted to do at the time. We wanted to write in Go. And that was very important because obviously Docker's written in Go. A lot of the tools related to containers are written in Go. It's more productive to write system software safely than other lower level languages. Those 4 constructs that I mentioned, the pods and the labels and the replication controllers and the services, they are the critical constructs of the system we run internally. Other systems, like Mesos, are largely monolithic. And what we wanted to do was build the simplest thing we could that works, launch that, get to 1.0, and then see, A, what other people would do, and B, what customers wanted and what we'd need to build afterwards. To that effect, we went for what we say over-modularity. In order for an ecosystem to emerge around these things, we needed to build something that was more modular than you might expect, so people can change parts out. And most importantly, we needed the cluster environment to be lightweight. We wanted it to be as easy to turn up and turn down a cluster as it was an individual VM. So again, low barriers to entry for people to try this stuff out. So talking about Mesos, Mesos was influenced by Google's papers on MapReduce, and it's primarily designed by researchers and engineers who have worked or interned at Google and then wanted a system like this to help them run other workloads. We published, again, the MapReduce paper. We published a paper on our second scheduling system first, actually, called Omega. We've only recently just published a paper on Borg about a month ago. But there's so much more to running and managing a distributed system than just providing compute space. And again, these are all the things John talked about before. It's not even the primary focus. You need to have load balancing and discovery. If you have a distributed system, you generally need master election. You need namespaces and service accounts and a way to attach and detach storage and things. These are the building blocks of any distributed system. This one happens to be built on containers because of all the advantages of being able to turn them on and off very quickly. Any distributed system has these problems. Now, even if you're running Mesos today, you don't just run Mesos. So you run something like Kronos or Marathon or Aurora. Apple, for example, are using Mesos now. They wrote their own scheduler. What we want to see is if your workload fits this path, run Mesos with Kubernetes on top of it. Run that next to, so you can have the Mesos part providing, so they call it a Twolevel scheduler, so it can provide resources via something like Yarn to Hadoop. And on the other hand, you have Kubernetes, which lets you run, so you have your batch workload over here, and your the real-time container microservices workload there. We haven't really focused on that batch workload for 1.0, but again, we have a system internally that's able to do both, so we may evolve in that direction. It really depends on what people want. But what we're doing here is letting Mesos focus on what they're great at, which again is hardware abstraction, resource pooling, running behind the firewall, for example. And then you can have the Kubernetes community and us contributing to that at Google focus on what we're good at, all the things that we mentioned before. So really we want to give you the message that if you target the Kubernetes API, you can run your workload absolutely anywhere. Now, I mentioned pods before. It's been really great to see that spreading out a little bit beyond Kubernetes. So one area that these slides have changed is, last time I gave this talk was before we announced the Open Container Project. And effectively what had happened was a few people who wanted to evolve Docker in a direction that they weren't necessarily interested in going in had started their own open specification and implementation of that. And now it's great to see the contribution of the Docker spec to a container project, open container project at the Linux Foundation. There's going to be a chance for that all to merge back in. So some of the things like AppC, for example, had in it code signing and provenance of containers is something that a lot of customers want to know. My cluster can only run signed workloads. For some enterprise use cases, they want that. Ultimately, the thinner a layer above the container runtime that Kubernetes provides, the better that it is for everybody. So we would love to see pods become a concept that exists in Docker. Hopefully with the convergence with AppC, we'll see that happen. I mentioned their Hyper, which is a container VM runtime. They're adopting the same thing. basically they want to have very lightweight VMs that are turned on every time you want to run a container to get rid of the security concern. Rather than having containers and VMs, you have each machine run a VM with a container, and again, it's all turtles all the way down. Every pod that you run inside a Kubernetes cluster, and again, remember, that's the unit of containers we run together, it gets its own IP address. And if you run, again, maybe 30 pods on a machine, each machine in your data center may only have a single IP address. We're all saying that one day we'll get IPv6. We haven't got there yet. But the question is, do I really need that? And then we have all these overlay vendors doing networking, SDN options. It's important to note that we didn't just arbitrarily decide this. This is an actual problem we have with our system as it exists today. If you run an application, if you want to start, say, 10,000 tasks on our internal system we know as Borg, all of those tasks get given a port on the underlying host machine. And again, that might be 10,000 machines. So when I want to talk to one or all of those things, I have to call out to a name server, which returns me 10,000 IP address and port combinations, and then I'll make a choice as to maybe which one I want to talk to. But now if we're using open source software, if we have Nginx and we want it to connect to Redis or anything, you would then have to write custom code to go off and talk to one of those service discovery things. A lot of these applications will let you specify in a config file, here are a bunch of IP addresses that run my service, but they generally expect it to be on the same port on all of them. So it's much easier to do this. You don't have to keep track of all of these ports. You don't need to worry about running out of them if the ports are the same on all of your replicas. Another thing that you can do in that case is if you don't have this and things are running on different ports, how can you do quality of service where I say traffic on this port is important because it's effectively every different one of my copies of my 10,000 copies of my task could be running somewhere completely different. So it's great to see that there's a number of solutions coming out in this space. Canonical launched one this week, but they're all basically some sort of SDN which allows you to have multiple IP addresses on each underlying machine, and that makes that problem go away. This is something cool that's been introduced recently to Kubernetes. It's a concept of a secret store. So you don't really want to keep your passwords and your OAuth keys and everything, tokens, inside your code. So what you can do is mount a volume, so you can attach secrets into your cluster and then attach that to a particular pod definition. And then those keys, that again provided by the operators rather than the programmers, they are made available appearing as if they're a disk, so you can mount them somewhere under /etc and just read the file. You don't need to rewrite your application to be able to talk to something else. It just reads the file. But because they're reusing TempFS, they never actually touch the disk, so they're not written to any of the nodes in your cluster. There's a great guy, if you ever get a chance to hear him speak, a friend of mine called John Wilkes. He's basically one of the authors of the papers we've mentioned before, a prime contributor to Kubernetes. He's saying, we don't want people to make the same mistakes that we did. Go ahead, make new ones, that's fine. Learn and do interesting things, but don't get the things that we did and do them wrong again. Now, very briefly, our 1.0 release plans, as promised. So where are we now? We launched on Monday our beta of Container Engine, the hosted product, and alongside that we are launching, and it should be out by now, what we're calling v0.20, which is the release candidate for 1.0. So any contributions now, if it's required for 1.0, we'll merge them as usual. If it's not, we're going to put it in a milestone to say after the 1.0 release, we'll come back to it and look at it then. Between now and launch, then we'll be looking at usability, performance, reliability, and documentation. However, the 1.0 API has been released, so this isn't going to change. We're committed to supporting this. When we rev to V2, you'll still be able to implement things on V1. Thank you for anyone who contributed feedback or helped shape this API. There's been a lot of changes even between these versions, and we want this to be backward compatible and last for a long time. We are holding a 1.0 launch event in July at OSCon in Portland, Oregon. There's now a website at kuberneteslaunch.com. There'll be live streaming of all of the events, so if you can't make it there, and I'm not sure, again, if anyone's going to OSCon, but do check out the live stream. So what 1.0 means is that Kubernetes is actually ready for production workloads. We've had some brave people who have been trying it. Their experience has helped shape things. But now we're at the point where we say, it's ready to run. I want to see a lot more hands up next time I ask, are we running in production? Because it's safe, it's ready to run, it has everything in that it needs. We're already working on things we want to introduce in V2, some features that are going to come out post 1.0. Now, I also want to mention at this point that after that launch event on the 6th of August, the Kubernetes London meetup group are going to have their third meetup, which will be at Code Node, which is Skills Matters' new venue in East London. And it'll be a sort of a Kubernetes 1.0 launch party. So again, that's something might be a little bit easier to get to than OSCon. And all going well, we'll have some guest speakers from the US over to talk at that event. Some of the things that are new and some of the things that are coming up. So the bold things are things we're hoping to get in, that will come after 1.0, I should say. So we get a lot of questions around auto scaling. So the two parts of that are, how do I give you more, how do I take the number of pods in my replication controller and make that number bigger? The mechanism exists. It's now just a case of deciding how big the number should be and feeding that in. And then also, how do I put more nodes into my cluster so I don't need to pay for these resources while the cluster doesn't need them? So we had, at the last Kubernetes London meetup, we had a couple of the engineers from Warsaw who are working on that come and give a talk. The slides for that are available online. But they, again, have a proposal which we're developing in the open about how we're going to address both of those things. I mentioned better batch job support. We're working on high availability masters. So at the moment, if your master goes offline, the cluster keeps running, but you can't schedule new work. And again, that's a nice, very easy fix. And one of the most important things from people I've spoken to, both in business and to developer use cases, is the idea of cluster federation. So for example, you might want to have some work which runs behind your firewall if you're a business or an education institute or someone who has to keep things in a certain place. But all the rest of my stuff can burst out to whichever cloud I want to or whatever other location. And we need a layer above that, so a federation layer, which we're lovingly calling Kubernetes, which lets you schedule work to different clusters. We don't really want to have one cluster span multiple zones, because then you might get cases where work's just given places that are not necessarily close to each other on the network, and then your replication things look weird because some of your nodes are further away than others. So that's the end of me. Thank you very much. Again, if you want to tweet, if you have any questions afterwards, I think we're probably running short on time, so we should keep them for the pizza. Thank you very much.
Thank you. Huh?